Let's look at this. Find the derivative of the following with respect to s using the first principle. Okay, x squared, 2s squared plus s plus 2, 1 over 2s plus 1, square root of s minus 1, s raised to power n, yn is a positive integer. Okay, so how do we solve the first one using the first principle? We're going to say let y equals to x, this x here. So the change in y equals to change in x. Okay, let's subtract y from both sides. If we subtract y from here now, this is remaining. We're going to have this minus y. What is y here? Y is x, because this says what? Y equals to x. It means that what? This and this will strike themselves out. We have these two. Let's divide both sides by delta x. We're going to have this over this equals to 1. It means that the derivative of s using the first principle is 1. Okay, let's try the second one. This time we're going to still say let y equals to s squared. Therefore, the change in y equals to change in s raised to power 2. Okay, if you calculate this, you agree with me that this is equals to this square minus y. So the y is equals to, this one, remember that the derivative of this guy from the first principle is the y over the x. Okay, that is equals to when this is approaching 0. Okay, that is this over this is equal to limit this approaches 0 equals to 1. Okay, we need to specify that we are talking about the y ds. As you've seen in one of the lectures, we have done that the disappearance of this is the appearance of this. We need to show that actually what we are talking about is that the derivative, the first principle we are talking about is the dy dx of x. Okay, the only way we can have the y ds is for this guy to first of all disappear towards what? 0. Okay, if you don't understand that, you will understand from here. Okay, now let's see. You are okay to this point from the first principle. If we expand this now, we're going to have s squared plus 2s this plus this square minus y, and y is s squared. Okay, then if we strike this and this out, we can boldly say therefore this is equals to 2x this plus s squared. Then we divide both sides by this equals to this, and this will go remaining this. Okay, so now to get the y ds now, the y dx, which is the first principle derivative, this guy need to approach 0. That's limit delta s need to approach 0. Okay, for delta y over delta x. Okay, is equal to, we still put this limit. You can see limit, this limit delta x approaches 0. This in place of this now, place of this, you agree with me, I can replace this guy with this, which is 2x plus this. Okay, so therefore if this guy is actually approaching 0 and now reach 0, you agree with me, what this guy reach 0, what is remaining will be only 2x. So the dy ds of s squared is 2x. Let's go for the third one. Is this right? Okay, let's go for it. That's to say let y equals to 2x raised to power 2 plus s plus 2. Okay, change the y equals to 2x plus change it x plus change in x plus 2. So let's substitute in place of y. We are going to put all this in place of y. That is 2s squared plus s plus 2 plus this equals to, this alone will give us s squared plus 2s change in x plus this square, okay, plus this one, that is s plus this plus 2. So work on this now. We're going to have 2s squared plus 4s changing s plus 2 this plus x plus this plus 2. So let's take every other thing to the right hand side. We're going to have only this remaining here. We're going to have 2s squared plus 4x changing s plus 2 this square plus x plus this plus 2. Then all this will come to be minus 2s squared minus s minus 2. So this and this will go, this and this will go, this and this will go. So what we have now is this equals to 4s this 2, okay, plus this. Let's divide everything by delta s equals to 4s plus 2 plus 1, okay. They will not bring the y there, and the only way we can have the y ds is if this change in s is approaching 0 for this over this. You agree with me? If that happens, this one automatically will go because this becomes 0, left with 4x plus 1. So we can conclude that what the y, the x of this question is 4x plus 1. Okay, now let's go for the fourth one, which is this. Let me solve it. Just follow me. I believe you know it now. Just follow me as I solve it. I believe you should be able to do this now. 1 over 2x plus 1. Okay, so let this one become this. So we're going to have, we substitute this for y, we have this. So this therefore is equals to 1 over 2x plus 2, this plus 1 minus 1 over 2x plus 1. So find the LCM of this. You agree with me? It's going to be this multiplied by this. So therefore here we're going to have 2x plus 1, this other side, minus 2x minus 2, changing x minus 1. So this is equals to this and this we go, this and this we go. We're left with this now all over. So let's divide both sides by delta x. So this one, you agree with me that if we divide this one by delta s, we're going to have this all over. Okay, now let's introduce the y dx now, which is equals to only when this guy is approaching 0. Okay, therefore this over this will give us minus 2. Any other thing that is dx here will be 0. So if this, we have 2x plus 0 plus 1, 2x plus 1, which is equal to minus 2 over 2x plus 1, 2x plus 1. Okay, and you agree with me that when you solve this now, you're going to have minus 2 over 2x plus 1 raised to the power 2.